Imagine standing on a quiet hill at dawn. The sky is a deep, slow blue. The world feels orderly, predictable, like a clockwork toy. You can almost hear gears turning somewhere beneath the grass. That feeling of a universe that ticks and talks, where everything follows neat rules, is the story of classical physics. Tonight, I want to walk you through that story, then pull the rug out from under it, and finally ask a question that has haunted thinkers for centuries. Where does the mind fit into the machinery of the world? Act 1, Classic Clockwork. Let's start with a simple image past physicists had used to model our world: tiny planets. When Isaac Newton looked at the heavens and the falling apple, he imagined the world as made of many little planets, like parts, each tugging on the others with a precise mathematical law. In Newton's picture, everything, planets, cannonballs, apples, even you, is a system of moving parts governed by universal rules. The future is written in the present. Give me the positions and velocities of every particle, and I can, in principle, compute the entire history of the universe. That's determinism in a nutshell. It's beautiful and terrifying. Beautiful because it promises order and predictability. Terrifying because it seems to leave no room for free choice. If the universe is a clock, then you and I are gears inside it. Our thoughts, our intentions, our sense of making decisions, under strict classical physics, look like byproducts. Philosophers call this epiphenomena. Real as the steam from a kettle, but causally impotent. Act 2, Einstein and the fabric of space. Newton's gravity had a problem. It acted instantly across empty space that bothered him. Enter Einstein, who rewove the stage itself. Instead of forces leaping across a vacuum, Einstein said mass and energy bend the fabric of space and time. Objects move along the curves in that fabric. Suddenly, the universe is not just particles moving in a pre-existing arena. The arena itself is alive, flexible, and part of the story. Einstein's insight rescued locality. Influences travel at finite speed, no spooky instantaneous action at a distance. It made the world feel more intimate and more constrained. But it did not solve the philosophical puzzle. If everything is still determined by local interactions and initial conditions, where does your choices, your sense of meaning come in? Act 3, the problem of the mind. This is where philosophy barges into physics. If the brain is just a complex machine of particles obeying deterministic laws, then mental life, the vividness of pain, the warmth of joy, the sting of regret, seems to be either one of two things. One, as something we mentioned before, consciousness is epiphenomenal, a shadow cast by brain activity that does not push back on the physical world. Or, alternatively, identity theory, the mind is nothing more than a pattern of physical processes. The feeling, such as pain and joy, is the same as the neural activity pattern we can observe in the brain. William James, the great psychologist and philosopher, pushed back on the epiphenomenal view. He argued that consciousness looks like an organ. It seems to help organisms survive, to select actions, to guide behavior. If consciousness never did anything, why would it line up so neatly with actions that benefit the organism? But to raise a deep conceptual snag. In classical physics, the mathematical description, numbers assigned to points in space and time, seems too thin to capture the richness of experience. You can describe the motion of every particle in a brain and still have no account of what it feels like to be that brain. You can imagine stripping away the feelings while leaving the motions intact. That asymmetry is the heart of the philosophical problem. Act 4, quantum mechanics enters the stage. Then the 20th century arrived and blew the stage apart. Experiments showed that classical ideas fail at the smallest scales. Quantum mechanics replaced the old rules with a new mathematical language that does not just describe particles out there. It ties the description to what we can know and how we measure. The Copenhagen interpretation, the version of quantum mechanics that grew out of Bohr and Heisenberg's work, is famously pragmatic. It says, physics is about the results of experiments and the knowledge we gain. The theory gives rules for predicting outcomes, not a picture of an objective reality independent of observation. That's a radical shift. The observer becomes part of the story. It ties predictions to the conditions of measurement, and those conditions are chosen by conscious agents. The theory does not insist that a human mind conjures particles into being. Rather, it insists that the act of asking a question of nature, the decision to measure this and not that, is woven into the way the theory links possibility to outcome. John von Neumann later formalized this and showed that quantum theory naturally separates into two processes. Process 2 is the smooth, deterministic evolution of the quantum state, which is the analog of classical dynamics. Process 1 is the measurement or the collapse, the moment when possibilities become a single outcome. Crucially, von Neumann formulation leaves room for the act of choosing which measurement to perform. That choice is not determined by the physical system being measured. It's an opening where agency, the human act of deciding what to measure, can enter without violating the mathematical structure of the theory. Act 5, a new way to think about mind and world. Quantum mechanics does not magically solve the hard problem of consciousness, but it changes the terms of the debate. In a quantum world, the strict classical barrier between quote-unquote what is out there and what is in here dissolves. The theory forces us to include the knowing subject, the scientist, the observer in the description. This opens two provocative possibilities. One, conscious choices matter. If the act of measurement involves a choice that is not fixed by prior physical states, then conscious decisions could play a causal role in the unfolding of physical events. Two, mind and matter are linked differently. Instead of mind being an epiphenomenon or a mere pattern, consciousness might be woven into the fabric of reality in a way that classical physics never allowed. Think of it like a play where the audience can sometimes step onto the stage and change the scene. Quantum theory does not say the audience always controls the plot, but it does allow for moments when observation and choice shape outcomes. It's rigorous physics. It's a mood, a way to feel the difference between a world that merely is and a world that responds. So what should we take away from this? As listeners, as thinkers, as people who wake up and make choices every day, science changed its story. Classical physics gave us a universe of gears and inevitability. Quantum mechanics taught us that the act of asking questions, the experiments we choose to run, is part of the scientific narrative. Agency regained a foothold. If the choices of observers are not fully determined by prior physical states, then our decisions might have genuine causal power. That does not mean free will is solved, but it means the door is open. Mind and world might be partners. The old divide, inner versus outer, mind versus matter, looks less absolute. Quantum theory invites us to explore models where consciousness and physical processes are in dialogue. Let me end with a practical image. Picture a scientist in a lab, hands hovering over an instrument. On the bench are many possible experiments, each a doorway into a different set of outcomes. The scientist chooses. The world responds. That moment, small, ordinary human, is where physics and philosophy meet. If you leave tonight with one thought, let it be this. Our best science no longer treats us as mere spectators. It treats us as actors whose conscious choices matter to the story we tell about the universe. That's not a metaphysical claim dressed up as physics. It is an invitation to keep asking, to keep experimenting, and to keep wondering how deep the connection between mind and world really goes.